All right. You're again welcome to our YouTube channel. And the presentation of this session is about the preparation of buffer solutions. It has come as a concern from very many students that we should attempt a number that involves how we would prepare the buffer solution of it can be preparation of any buffer solution. This is an acidic buffer. The fact that you're having a weak acid, it means that for it to be a buffer, we need a salt of a strong base. Now, if they said describe how you would prepare a buffer solution of pH 5 given Ka, this is very easy as one could imagine, but we do not need to start describing an experiment, what not really. We need to derive a mole ratio between ethanoic acid and the salt, or between the acid and the salt that we use to prepare that buffer solution. You have to, in your mind, be knowing that for you to form this buffer, the fact that it is a weak acid, we need a salt of a strong base, which can be a sodium ethanoate, something like that. So we shall be using Anderson-Ashbach equation to get this ratio between the salt and the acid. And then from there, we make a conclusion on how we would prepare it. So we shall say that pH is equals to pKa plus logarithm to base 10 of the concentration of the salt out of concentration of the acid. So our pH has been given as 5 is equals to pKa. We are given Ka, so we shall say negative logarithm of Ka, which is 1.8 exponent negative 5 plus logarithm concentration of a salt. Concentration of a salt, we don't know it, do we? No, we don't know the concentration of a salt, so shall have concentration of a salt out of the concentration of a base. No, sorry, acid. But of course, we know that the salt 5 is equals to, when you take the negative logarithm of this, it will give you 4.745 plus logarithm concentration of a salt that we can derive would be sodium ethanoate, and an acid, of course, is automatically ethanoic acid. Now, when you bring this one this side, it will be 5 minus 4.745, and this will give us 0.255 would be equaling to eliminate the logarithm here. Anyway, it can keep a ratio of logarithm concentration of sodium ethanoate out of concentration of an acid, ethanoic acid. All right. Since this is base 10, we can take the antilog of this so that our concentration of sodium ethanoate over the concentration of ethanoic acid is equaling to 10 power 0.255. So this one will give me the ratio of ethanoate of when you take the power of this, it's going to be 1.799 out of 1. What does it mean? Here, it means that the mole ratio of sodium ethanoate to ethanoic acid is equaling to 1.799 to 1. What does it mean? It means that the buffer solution will be made by preparing, will be made by dissolving 1.799 moles of sodium ethanoate, okay, and you dissolve them in 1 mole of ethanoic acid, of which you can also convert these ones to their respective masses if you get the molecular masses. So let's say therefore a buffer solution is prepared by dissolving 1.799 moles of sodium hydroxide in 1 mole of ethanoic acid. As simple as that. Or one can convert these moles to mass by getting the molar mass of sodium ethanoate and then the mass of ethanoic acid, and then you get masses. So it will be dissolving the other mass. You can as well convert these ones to masses, and then you express your conclusion in terms of masses. As simple as that. So still get the molar mass of this, get the molar mass of this, multiply by the moles. Then you get the mass that is dissolved in the masses that are mixed to make 1 liter of a solution of a buffer. So that is how this question is attempted. So the main thing here is to use the Henderson-Asselbach equation, and you get the ratio of a salt to the acid, and then you make a suitable conclusion. I'm going to give you, before I give you, let me first conclude that. They want us to talk about the biological and industrial applications of buffer solutions. Let me first list some here, then we categorize them. Buffers, the first application, well, buffers can be used in maintaining the pH of the body since there is no pH changes, right? So we can say use it in maintaining pH of blood plasma constant in the body. We can as well use it in preservation of food and drinks. We can as well use it in maintaining pH during the fermentation process. We can as well use buffer solutions. We can as well use it in labs to prepare standard solutions. Prepare standard solutions of definite pH. That is it. So you can categorize them. This is biological, maintaining, they needed 1-1. Almost all of these ones are industrial. All of these ones are industrial. So there we can go. So I'm leaving you with a question, our viewers. I'm leaving you with a question. Which question has to be done by us, and we see maybe how best we have moved. Activity. Describe how an acidic buffer solution of pH 3.5 can be prepared using methanoic acid of pKa, pKa value of methanoic acid 3.75. That is it, our viewers. We love you so much. Keep subscribing, share the link, like, comment. That one gives us energy. Till next time, we are going to start salt hydrolysis, from which we shall move to chemical kinetics in our physical chemistry. Nice time.